So we took some time to find the transformer location. This is a little unusual. Really, it's just lighting on the front of the house, but the transformer is all the way back in the back patio. So this must have been built before the patio was put in, because I imagine there's piping going out, which we'll trace that. But it's a Vista transformer. My guess is about 2011, and there's a date code on it. One thing that these transformers are kind of known for is there's a coating on it that peels off, even though it's stainless steel. Outlet's up high. It's not in an ideal location, but it's serviceable. It does have a GFI. We tested it, and the GFI is working. We'll do some more tests on the electric, but just a preliminary test is we turned it on. The transformer did turn on. And Josh, what do you think of this transformer here? Probably 20 years old?
Give or take, yeah. One thing I notice is a 900 watt transformer. So it's with the old halogen system. You needed the bigger wattage transformers to power those halogen bulbs, but we don't need nearly that much power. So the good thing is this system, once it's swapped out, will be powered well.
Yeah. Voltages, it's a 15 volt transformer, so it meets code on that. As you said, huge transformer. The great thing about transformers, they're basically a magnet with wire coils around it, so very few things go wrong with transformers over time. So I've seen transformers last 30, 40 years. So this is a transformer that we can use, even though it's 900, with an LED system, we're probably at like 130 watts total, 140 watts total. So we have more than enough capacity. So the next thing we're going to look at is what the voltage coming out is, what the overall amperage is, and what the amperage is on the low voltage side. So Josh, if you could go ahead and show like what you're doing with your tester.
Sure. So the transformer's old. It might look cosmetically fine, but a lot of the things that go bad with the transformer happen on the inside. So I'm going to go and I'm going to test every terminal to make sure there's no loose connections that are affecting any of the terminals. And then I'm going to check the amperage to see what we have on each of those 3 lines.
Yep. So first thing, setting your voltmeter, make sure it's not on DC, right? Want me to hold it?
Yep.
I'll hold that up here.
So you have 3 circuits. So I'm going to test the 1 to 11. And I'm going to go right across all of them.
13, and hold it on that one for a second.
14.
14.01, that's on the 15 volt?
That's on 13. So
okay,
it's
running a volt high. That's one way they cheat, but everybody does it.
It's actually nice when they run high. So it's 15 on 14. And so all of the supply lines are good. So I'm just going to tap it on these other commons to make sure they're good. So everything's testing fine. There's no reason we shouldn't be able to use this transformer. Yeah. Now the wiring's a different subject. The wiring, it determines how many wires are going up front, what we're going to be putting on each wire.
Yeah, we'll go through a line load calculation. One thing that's good is code on a transformer is 12 inches above grade. So we always want to be above 12 inches. This is about 30 inches, 36 inches above grade. If I'm 6'3", that would be about right there. They piped it all in, which is good. It's not sealed here. That's an option you could do to keep ants and everything, but there isn't an ant infestation or anything like that, which is great.